Hello and welcome back. In this question, we analyze the reliability of a COVID PCR test using probability. Okay, so the question is all about of people having COVID, 90% of the test detects the disease, but 10% goes undetected. Okay, and of people free of COVID, 99% of the test is just COVID negative, but 1% are diagnosed, means the result is positive. Out of a large population, only 0.1% have COVID. One person is selected at random, given the COVID PCR test and the pathologist report him or her as a COVID positive. Okay. So now let us define the events. Okay. Let C be the event where person has COVID. C complement, person does not have COVID. C plus, test is as positive. Okay. So PC will be person has COVID means 1%, okay, sorry 0.1%, so 0.1 upon 100, this will be 0.001. So PC complement will be 1 minus 0.001, so this is 0.999. Okay. Now probability of tested as positive when they are actually COVID patient, so this will be uh, 90% means 90 upon 100, this is 0.9, and probability of tested as positive when they are not COVID patient, so this is 1% means 1 upon 100, this is 0.01. Now the first question is, what is the probability of the person to be tested as COVID positive given that he is actually having COVID? Okay, so this question properly fits in this condition, so the answer will be 0.9. The second question is, what is the probability of the person to be tested as COVID positive given that he is actually not having COVID? So another conditional question, and this is the proper probability, so the answer is 0.01. We will mark option A as the correct answer. Now the third one is, what is the probability that the person is actually not having COVID? So the person is actually not having COVID is C complement, means probability of C complement is given as 0.999. So the answer will be B. The fourth question, what is the probability that the person is actually having COVID given that he is tested as COVID positive? So this is asking about reverse probability. So we will use Bayes theorem in this question. Okay. So the answer will be nothing but probability C plus will be 0.9 into 0.001 upon 0.9 into 0.001 into, sorry, plus 0.01 into 0.999. On simplifying this, we will get 0.0009 upon 0.01089. So this is gonna be equal to 0.083. So we will mark option C as our correct answer. Now the fifth question is about what is the probability that the person selected will be diagnosed as COVID positive. So there are two cases, and both the cases are alternative. Like if the first happens, second will go unnoticed, and if the second happens, the first will go unnoticed. So we'll simply add the probability of both the cases. So the answer will be 0.9 into 0.001 plus 0.01 into 0.999. So this goes around 0.01089. So option correct is option number B. So what's the final conclusion? The this problem shows that a positive test does not always means the disease is present. When a disease is rare, false positives can significantly affect the result. This is why Bayes theorem is very useful in real life situation. Okay. See you in the next video. Till then, keep learning.